Okay, so welcome back. Today we're going to talk about cosine law. So cosine law is another option that we have for when we're dealing with triangles that aren't right angles. So cosine law can be used on any triangle. I'm just going to write this cosine law out. I've talked about cosine law before. Cosine law starts as follows. It starts with c squared equals a squared plus b squared. So basically, not basically, this is Pythagorean theorem, right? So Pythagorean theorem, and that's why I've always encouraged you to remember it like that. So it starts out with Pythagorean theorem, c squared equals a squared plus b squared, and then it's minus 2ab cosine of uppercase c. Now notice all these other letters, right? All these other letters are lowercase. So lowercase, 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 lowercase. However, this one is uppercase. And if we recall back, the reason for the difference in letters is that one means that this is going to be an angle, and all of the other ones are side lengths. So c squared equals a squared plus b squared minus 2ab cos c. And so we can use this. We can use cosine law to find both unknown angles as well as unknown side lengths, but there's only certain circumstances where you're eligible to use this, as well as certain circumstances we're eligible to use sine law. So after we're done this lesson, next lesson is going to be, I'm going to show you a decision tree that will let you decide what version of what law you need on what triangle. But for now, we're just going to look at the mechanics of cosine law. So easiest way to see it is for me to draw one of these out. So I'm going to draw out a triangle. All right, so here goes a triangle. And I'm going to tell you that, I don't know, this looks to be about 24 degrees. This is 15 centimeters, and this is 17 centimeters. And what we're interested is in the x value right there. So I'm going to just work through this first one as I would normally do in class, and then I'm going to write out the cookbook recipe of how to use cosine law. But here we go. So with cosine law, the letters are important. With sine law, we said we could put the letters anywhere we wanted. With cosine law, it's more like SOHCAHTOA. It's more like primary trig ratios or Pythagorean theorem even. And so cosine law, the C, the uppercase C, has to go on the angle we know or the angle we want to know. So it's a lot like our theta. So there's my uppercase C, which means that lowercase c is going to go over here, and then A and B can be either of the other two sides. Okay, so we have c squared equals a squared plus b squared minus 2ab cos c. So in this case, lowercase c is x. So we're going to have that x squared is equal to a squared, which is 17 squared plus b squared, so 15 squared, minus 2 times 17 times 15 times the cosine of 24 degrees. Okay, so we do those substitutions. And really, if we look at this, this is all just numerical, right? So we have this set up, it's all just numerical. So what I can do is I can type this directly into my calculator exactly as it appears. Now, I know that often you're encouraged to not type everything in one go. With cosine law, particularly if you have a two-line calculator, I advocate typing this whole thing in at once. We need to make sure that our calculator is in degrees. Mine is not in degrees. So I'm going to go across and put it in degrees. Then we're going to type this in. So we're going to have 17 squared plus 15 squared minus 2 times 17 times 15 times the cosine of 24. And we can type that in, hit enter, hit equals. We're going to get 48.09. So I'm going to go back here and say, all right, this is 48.09. Now, we're not quite done, obviously, because this is what x squared is, and I don't want x squared, I want x. So I'm going to root both sides. So root this side, and I'm going to end up with x equals, I don't know, like 6.95 or something like that. So let's take square root. So square root 6.93. Okay, so 6.93. There we go. 6.93 centimeters is how long that unknown side is. Okay, so I'm going to I'm going to list out our cookbook recipe. We've done one example, and then I'm going to give you a few examples to try working through. Okay, so our first step, step one in our cookbook recipe, is we are going to place the uppercase C on the angle we know, or the angle we want to know. Okay, so there's the first step. Step two. Step two is going to be, let's grab a different color here. Step two is going to be label off the sides with A, B, and C. And of course, C has to go opposite where we put our uppercase C, but we know that. So label off the sides with A, B, C. Notice those are all lowercase, that's uppercase. Okay. And really, it's not a complicated process. Step three is going to be substitute all values into C squared equals A squared plus B squared minus 2AB cos C. And then step four is going to be solve for the remaining unknown. Excuse me. So there you go. That's it. Like it's a much shorter process than some of the other things that we've worked on. So what I'm going to do is I'm going to draw out another example that I would like you to work through. Okay, so here goes. Let's grab a different color here yet again. Whatever color that is. Okay, so another example. So here we go. So here is a triangle. And let's say that this looks to be 55 degrees, and this side is 10 meters, and this side is 12 meters. Okay, there's my X. So I'd like you to go ahead, pause the video, and then give it a whirl and come back as soon as you're done. All right, welcome back. So our first step, put our C, uppercase C, on the angle we know or we want to know. Well, here's the angle we know. And I haven't really asked for these other angles, so that's where our C is going to go. So then we're going to label off our sides. Well, this side's got to be lowercase c, and this is A, and this is B. So I'm going to take C squared equals A squared plus B squared minus 2AB cosine of uppercase C. And we're going to substitute those values in. Well, our lowercase c is x, so there's x squared equals 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 55 degrees. And again, when we're in this position, we can just go ahead and we can substitute directly into our calculator, drop that all in one go. So we're going to have 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 55. Drop that all in, and we're going to end up with 106.34. So we've got now that x squared equals 106.34, but we don't want x squared, we want just x. So I'm going to root both sides. We're going to get that x is equal to, let me grab my calculator again, to the exponent 0.5 for a square root. And we're going to get 10.31. So we just found that x was 10.31 meters in length. Okay. Let's do one more straightforward example like that, and then we'll make it a little bit more challenging. Let me grab a different color here. So I'll move over here. Looks like the same color to me, but I'm sure it's different. There we go. So this is example 2. And let's say that this was 73 degrees. Okay, so there's 73 degrees. This side is going to be 4 kilometers. This side is going to be 7 kilometers. And I'd like you to solve for x. So go ahead, pause the video, finish that up, give it a whirl, and then come on back. Well, welcome back. So our uppercase C is going to go on the angle we know where we want to know. So it's going to go here. It means that lowercase c is going to go here. And this can be a and b. Again, the a and b don't really matter where they are. So we've got c squared equals a squared plus b squared minus 2ab cosine of uppercase c. Drop those values in. So we're going to have x squared equals 7 squared plus 4 squared minus 2 times 7 times 4 times the cosine of 73 degrees. Okay. Drop that all into our calculator. Grab my calculator here. Here goes my calculator. So we're going to have 7 squared plus 4 squared minus 2 times 7 times 4 times the cosine of 73. And so that is 48.63. So we've got x squared is equal to 48.63, but I don't want x squared, I want x. So I'm going to root both sides. So I do that, and we're going to find out, I don't know, like 6.9 again-ish, to the exponent 1.5, and 6.97. There we go. So 6.97. And that was kilometers. There we go. So those are pretty straightforward examples. Now, what we've used this is we've only used cosine law so far to find an unknown side length, but cosine law can also be used to find an unknown angle. So let's use it to find an angle. So where are we at? There we are. So finding an unknown angle. So the cookbook ends up being the same as what we had before, but this is a bit more of an involved process. So it all starts out the same way. So let's draw our triangle. Here we go. And imagine that we said this side was 8 meters, this side was 6 meters, and this side was 9 meters. And what we really wanted to find was, we want to know what that angle right there was. Okay, so there's an angle. Cookbook recipe starts out the same way. It says put the C on the angle we know where we want to know. Well, this is the angle we want to know. So here goes my C. Means that this side's got to be lowercase c, and then a and b can go wherever you want them to. So the formula is the same. C squared equals a squared plus b squared minus 2ab cosine of uppercase c. So in this case, c is 6. So now look, this isn't a variable on this left-hand side now, it's a value. So this is going to change things up. So we're going to have that this is 8 squared plus 9 squared minus 2 times 8 times 9 times the cosine of, oh, there's our x right there, right? So process is the same up until this point. Put the C on the angle we know we want to know, label a ring off, and substitute everything in. Now, the last few examples we've done, this chunk right here has been all values, and we could just type that directly into our calculator. But in this case, obviously, we can't because we've got our variable on this side. So the evaluation of this becomes a little bit different. So we're going to have to be really careful with our process here. So we're going to just simplify each of these numerical expressions. So 6 squared is 36, 8 squared, 64, 9 squared, 81, 8 times 9 is 72, times 2 is 144. So minus 144 cosine of x. All right, so we've done some simplification. This is where students often get it wrong. A lot of students want to do this plus this minus this. And that's not what it's going to be, right? Because this 144 is multiplying the cos x. So we can take, this is a constant term, this is a constant term. And we can add those up right now, or we can move them. I prefer to move them first. So I'm going to move those both to the other side. Well, over here they're positive. So on the other side, they're going to be negative. So we're going to have 36 minus 64 minus 81 equals negative 144 cos x. Okay, good. take this, drop this into my calculator. So I'm going to grab my calculator, type that in. So we're going to have that 36 minus 64 minus 81 is equal to negative 142. So over here we have negative 142 is equal to negative 144 cos x. All right, so now we're closer to where we want to be. We want to get this x all by itself. I know the very last line of my solution should be, some value is equal to x. And this would be our answer right here. So we have to undo what's happening to it. Well, negative 144 is multiplying cos x. So the opposite operation of multiplication by negative 144 is, of course, division by negative 144. So divide both sides by negative 144. Those are going to go away. And we're going to have that the cosine of x is equal to this. Now, I could type that into my calculator. It's not a very nice number, right? So negative 142 divided by negative 144. Type that in. Yeah, not a nice number at all. 0.9861 repeated. And if you have a one-line calculator, you might be kind of forced into doing that. Thing is, we really want to keep all of those decimal places. So I'm going to just leave this over here as negative 142 over negative 144. And I want to get the x all by itself. Well, what's happening to the x right now? Cosine is happening to the x. So the opposite operation of cosine is cos inverse. So I know that over here, we're going to have the cos inverse of negative 142 over negative 144. And we're going to drop that into our calculator. So two-line calculators, this is pretty easy. So we just say second function cos inverse of negative 142 divided by negative 144. And as long as that's inside brackets, we're good to go. I type that in, and we find out that that is 9.56 degrees. And so we're good to go on that. We get that it is, of course, 9.56 degrees. I don't think I've typed that in wrong. Oh, I made a mistake up here. Dang it. So I'm going to go back up and make a correction. So we're going to take and we're going to do, this is going to be 36. I didn't see that. Minus 64 minus 81. So hopefully some of you spotted that along the way. So this is meant to actually be negative 109. So I'm going to have to go up here and make a correction. So I'm going to grab my eraser. There we go. Come back. Eraser. So that's negative 109, that's negative 109, and that's negative 109. Hopefully some of you spotted that. All right, so go back to where we were. Grab this. So that's meant to be negative 109, negative 109, and negative 109. All right, so let's try that again. So grab my calculator. We're going to do second function cos inverse of negative 109 divided by negative 144. So close that off, and we're going to get 40.80, which is much more reasonable angle there. So this is 40.80 degrees. So my apologies for having made that mistake. But there we go. There is the unknown angle. It is 40.80 degrees. So let's try another one of those. And this time I encourage you to pause it, give it a whirl, and try it on your own. So here we go. Grab a different color, whatever color that is. So here comes another triangle. And I'm going to tell you that this side is 10 centimeters. This side is 16 centimeters. And this side is 15 centimeters. And this time we want to solve for an x right there. So go ahead, pause it, give it a whirl, and then come on back. Okay, welcome back. So according to my cookbook recipe, I need to put a C on the angle I know where I want to know. So there's my C. That means that A and B can be on the other two vertices. Doesn't really matter where they are. So this is going to be little c over here, and then this is going to be little a, and this is going to be little b. So I know that it is c squared equals a squared plus b squared minus 2ab cosine of uppercase C. So little c is going to be 16 squared is equal to 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of 16. No, the cosine of x. So get rid of that. So it's a cosine of x because this is uppercase C and this is uppercase C. So there we go. Substitute everything in. Now we want to do some simplification. So I'm going to simplify each of these chunks. So 16 squared, I believe, is 256, but I'm going to just check that. So 16 squared, yeah, 256. So come back here and say this is 256 is equal to, I know that's 100, plus 225. 150 times 2 is 300, so minus 300 cosine of x. All right, good start. Going to move this over, going to move this over. They're both going to become negative. So we're going to have 256 minus 100 minus 225 is equal to negative 300 cosine of x. Type this into my calculator. Okay, so we're going to have 256 minus 100 minus 225, and we find out that that is negative 69. So we've got here negative 69 is equal to negative 300 cosine of x. I'm going to divide both sides by negative 300. I'm going to divide by negative 300. Those guys are going to go away. And so now we're in a little bit better position. So now we've got the cosine of x is equal to negative 69 over negative 300. I'm going to cos inverse both sides. So we're going to have that the cos inverse of negative 69 over negative 300 is equal to x. And so I'm going to type that in my calculator. Okay, so we're going to type that in. So we're going to have second function cos inverse of negative 69 divided by negative 300. Type that in, hit enter, and we're going to get 76.70. So we just found that that unknown angle is 76.70 degrees. Okay, so there's how we can use the cosine law to find both an unknown side length and an unknown angle. Now, tomorrow we're going to look at our overall triangle decision tree that will let us be presented with any old triangle, and we have all of the tools at our disposal that we can possibly use. So far that means we can use Pythagorean theorem, we can use SOHCAHTOA, we can use sine law, and we can use cosine law. But the decision of what tool to use when is one that often gives kids difficulties. So I'm going to post some more questions for you to practice with this stuff, and I'll have another lesson ready for you tomorrow. Okay, thanks guys. Bye.